Okay, so the practice question's on page 517. Number 14 says, find the de Broglie wavelength of a deuteron of mass 3.3 times 10 to the negative 27 kilograms that moves with the speed of 2.5 times 10 to the 4th meters per second. So we have a mass, and we have a speed, and we want the de Broglie wavelength. So we're going to use lambda is equal to h over mv. So 6.626 times 10 to the negative 34 joule seconds. It tells us the mass is 3.3 times 10 to the negative 27 kilograms, and the speed is 2.5 to the 4th meters per second. And if you do the math, you should get lambda to equal 8.0315 times 10 to the negative 12 meters. It's itsy bitsy. All right. Number 15. What is the de Broglie wavelength of a proton moving with a speed of 1 times 10 to the 6th meters per second? The mass of a proton is 1.67 to the negative 27. We've actually been using 1.673 to the negative 27. So I'm going to use that. If you used 1.67, no worries. Our decimal will just be a little bit different. But it's still lambda equals h over mv. So it's still 6.626 to the negative 34 joule seconds. The mass is 1.673 to the negative 27 kilograms, and 1 times 10 to the 6 meters per second. Do the math with your calculator or in your head again, and you should get 3.961 times 10 to the negative 13 this time for lambda. I could do the 1 to the 6th in my head. All right, number 16 says, an electron is accelerated across a potential difference of 54 volts. Find the maximum velocity of the electron for part A. So it's an electron, so we know its Q is 1.602 to the negative 19 coulombs. So if we have Q and we have V, and we're looking for speed, we need to use the equation V equals W over Q, which of course is the kinetic energy. 1/2, I don't know how I'm going to make an M out of that, mv squared over Q. And we're looking for V, so a speed. So bring the Q over, multiplied by 2, divide by M. So V squared is equal to 2QV over M, or 2 times Q, 1.602 to the negative 19 coulombs. V was 54 volts, and the mass of an electron, if you remember, is 9.109 to the negative 31 kilograms. And remember, that's going to be the speed squared. You're then going to have to take the square root. And when you do, you should get a speed of 4.358 times 10 to the 6 meters per second. Okay, now I had someone one year where they'd write down V is equal to 54, and then they just use it in this 1/2. They use it as speed. They just make the V tiny. And it's like, no, because see, it's still in volts. Whether you make the capital V tiny or not, it's still in volts. So you actually have to do something to change it to speed other than just make the V smaller. Letter B, calculate the de Broglie wavelength. So now that we have the speed, then lambda equals h over mv. So lambda equals 6.626 to the negative 34 joule seconds. It's an electron, so 9.109 to the negative 31 kilograms, and the 4.358 to the 6th meters per second. Lambda equals, and you should get 1.669 to the negative 10 meters. All right, number 17 says a neutron is held in a trap with a kinetic energy of only 0.025 electron volts. What is the velocity of the neutron? So it's telling you the EK is 0.025 electron volts, which of course you have to change to joules. So 1.602 times 10 to the negative 19 joules per electron volt. And then it wants the speed. So once you get this, then you're going to set it equal to 1/2 mv squared. So v squared is going to equal 2 times this 0.025 eV times 1.602 to the negative 19 joules per electron volt divided by, and this is a neutron. Interesting, they told you the mass of the proton earlier, but they didn't tell you the mass of the neutron here. But it's almost the same as a proton. It's 1.675 to the negative 27 kilograms. So it's just slightly heavier than a proton. Remember, that's going to be v squared, and you're going to have to take the square root. And when you do, you get 2.1868 to the third meters per second. So that's part A. Part B says, what is the de Broglie wavelength? So then lambda equals h over mv. So 6.626 to the negative 34 joules seconds. M is 1.673 to, 5 times 10 to the negative 27 kilograms. And our speed is 2.1868 times 10 to the third meters per second. Okay, punch all of that into your calculator, and you should get 1.809 times 10 to the negative 10 meters. Okay? Number 18. The kinetic energy of a hydrogen atom electron is 13 point, I can't even see if that's 6.5. Yeah, 6.5. I think I need my new glasses. Find the velocity of the electron. So it's just like what we did up top, only this time it's with an electron, not a neutron. So in 18 they gave us, the kinetic energy of the neutron. This time they're giving us the kinetic energy of the electron, 13.65 electron volts. And it's asking us find the velocity. So again, we know that EK is equal to 1/2 mv squared. So v squared is going to be equal to 2EK over m. K over m. So 2 times 13.65 electron volts times 1.602 to the negative 19 joules per electron volt, and the mass of an electron 9.109 to the negative 31 kilograms. And remember, this is v squared again, so you are going to have to take the square root. And when you do 18, you should get 2.191. 2.191 times 10 to the 6th meters per second. It's part A. Part B says, calculate the de Broglie wavelength. Imagine. Lambda equals h over mv. At some point they should give us the lambda and make us rearrange this, don't you think? 6.626 to the negative 34 joules seconds. Mass of an electron, 9.109 to the negative 31 kilograms. And 2.191 to the 6th meters per second. And we get a lambda of 3.0